an algorithm which is there in public key crypto system, and its name is RSA. So we'll see what it is. We'll see the algorithm, and we'll try to solve one problem which is related to your RSA. So that's what we'll be trying, and we'll be at the end we'll be trying to understand. Okay. So let's start our discussion. Let me share my screen first, then I'll start the discussion. Okay. Okay. So I hope this is visible to all of you. Uh, so let me start with um, its history. Or first of all, let's talk about like what is the topic of discussion, and after the completion of the lecture, what you're going to be understanding and what you'll be able to get from the lecture. So, in today's session, after the completion, you will be able to learn about the history of RSA, what it is, and how it came into picture, and why it became so important. We'll analyze the RSA algorithm. We'll perform the encryption and decryption using RSA. We'll be able to do that, and finally, we'll talk about the security of RSA. So, these all four topics are what you'll be learning by today's end and by this session's end. And I hope that you understand each and everything properly. Also, one thing which I'd like to tell that be ready with a pen and a paper so that if I give you any problem, you should be able to solve it. So be ready with it, and let us take a look about the history. Uh, when we talk about RSA's history, after when your public key cryptography came in '76, uh, a new branch of cryptography, it was suddenly opened up to all the scientists and the researchers throughout the world, and they started looking for a method which is some methods and some cryptography which can use public key concept, public key cryptography concept, and can be used for various different purposes. Okay, so those purposes can be for encryption or for key exchange or for different ways. So they started using public key. They started looking at public key to get some good answers regarding some common problems which is related to cryptography. So what happened in 1977? These are the people who are involved. Uh, the first person is your Ronald Rivest, then Adi Shamir, and then the last person is Leonard Edelman. So these three are the main people who are involved in the development of this asymmetric cryptographic scheme, which is known as RSA. Okay, so these three are the people who are involved in um, making of it. And why RSA name came? It is because of the initials of their name. So R, S, and this is your A. Their main their names initial are taken as a name of this cryptographic algorithm. And this picture I think I have taken from Wikipedia or I don't know some other sources. So these three are actually the people who are involved in uh, development of RSA, and they worked a lot and they came up with a very beautiful algorithm which is used for encryption. It can be used in digital signature, and it can be used for even key exchange. So we'll see about it. Let's talk about it. Some a bit more of a background on it. Um, Sometimes this is also called as Rivest-Shamir and Edelman algorithm, and currently it is the most widely used asymmetric cryptographic scheme. So it's the most widely used. Okay, it's most widely used. The reason because it is simple, yet it is complex to break. Okay, so that is one good thing about RSA. It's simple, but it is complex to break. And even though your elliptic curve and some discrete logarithmic encryption schemes and these kind of algorithm came or were gaining around, but still this RSA didn't got outdated, and still it is being used by many people, and it's very much uh, because of its, because of the simplicity and because of its uh, difficult to break it. It is very much relevant to us, and it was patented in the US until 2000. So this was like when it was patented in the world. Um, then there are many applications for RSA, but in practice, mainly we'll be using it for these two purposes. People use it for mainly these two purposes. The first thing is encryption of small pieces of data. So if you want to encrypt some data which is very small in length, small means that which, for example, the key of an encryption algorithm, which can be like 56 bit or 60 bit or whatever it is, 64 bit, it's up to us. So if it is small, if the data is small, then we can go with the your what they call RSA. The reason behind that, or the reason for that is uh, because it itself, if you're having a very huge data, then the whole process actually becomes a bit more slower. So that's the problem why we don't go with huge amount of data. For small data, there is no problem. That it will take normal amount of time, nominal amount of time for encryption. So encryption for small pieces of data we can use it for. Then we can also use it for digital signature. So generating it and um, for digital certificates on the internet, for creating those digital certificates, you can use it. But in today's session, our main discussion is mainly on encryption. So how to do encryption using RSA. So that's what we'll be understanding. That's what we'll be learning today. So let us move forward. This is actually the whole algorithm. Algorithm can be broken down, or it can be broken down into two, or rather three steps. You can say that for encryption, two steps; for decryption, two steps. Okay. So this first step talks about the key generation. So this is the key generation part. Um, and next one is like encryption, and the third one is for the decryption, the receiver side. This is for the at the sender side. This is at the receiver side. And key generation will be done uh, to whom we are sending. So either it can be done at the both the sides, but for an individual, if I want to create a public key and a private key, then it should be done by me rather than doing by anyone. So I'll give you a scenario. What is working in this one, in this example? Here, we are having two persons. One person is Bob, and another one is Alice. Okay. So Bob and Alice, they both want to, or not both, but rather Bob wants to send a message M to Alice, and it should reach as a ciphertext C. Okay, so this is what is going on. This is what we want, and this is how the algorithm is being written. Now, the first step is the key generation at Alice. So here, now we are working here, like how to generate the key for Alice. The same way it can be generated for Bob only, but in this case, why we are talking about Alice? Because see, this plain text M should be encrypted with RSA algorithm, okay, and your key, or rather, I can write it like this to be more accurate. This plain text M should be encrypted with the public key of, or I'll use the same notation here. It can be written in different ways. So I'll just write down public key of your LS. So this M should be encrypted with the public key of LS by using RSA algorithm. Okay, so this is what we want. And here, this C must be decrypted with the private key of Alice using RSA algorithm. If you remember earlier when we talked about how to do encryption, this is the way to do encryption, right? So if Bob wants to send something to Alice, so Bob must use the public key of Alice for encryption, and only Alice can decrypt it because it can be decrypted using the private key of Alice. So this is what is happening here. This is what's going on. Now I'll tell you how this whole structure works. So there are actually 7 steps which are present. So I'll just mention them. I'll tell them what are those. The first step talks about we need to select two value, that is P and Q. Now what are these P and Q? P and Q are actually both prime numbers where P is not equal to Q. But in the real world, these both prime number has also one more constraint, that it must be large prime numbers. It must be large prime number. So peak should be of length, let's say 5 digits. Q could be, let's say, 7 digits, like that. It should be large. Why we are talking about large? Because here lies the security of RSA. Okay, what is that? I'll tell you. Don't worry about it. When we talk about the security, I'll talk in detail about this part. All right. Now, uh, we need to calculate. The second step says that we need to calculate the values P and Q. Okay, so we need to calculate the value P and Q. Sorry, we need to calculate N, which is actually the product of P and Q. I'm sorry about that. We need to calculate N, which is the product of P and Q. The third step says that we need to calculate this Euler's Totten function, where its value phi of n is actually P minus 1 into Q minus 1, which you have already learned earlier. So anyway, this is simply P, whatever P value is there, P minus 1 multiplied by Q minus 1. That's it. Fourth step says that you need to select an integer E. Now, how to select this integer? There is a condition. This integer E and this phi of n must be co-prime with each other, meaning the GCD should be only 1. So it means the GCD of phi n and E must be equal to 1, and E's value must range between 1 to phi of n. That is the range of E. Okay, so mathematically it can be told in a different way, but I'm not going to, because here I need to, if I want to explain it to you, I have to again talk in terms of ring, the range of the ring. So here we are not going into detail of that, but simply you should understand that E should lie between 1 to phi of n. Now, and also your GCD of phi n and E must be equal to 1. So this is the fourth step. Let's come to fifth step. Fifth step says that you need to calculate D. Now, what is D? D is actually congruent to E inverse mod of phi n. Okay, or in some other sense, you will, or in some other place, you will also find it written like this: D multiplied by E is congruent to 1 mod your phi n. Now this can also be written like this, right? So there is nothing but the same thing. Both represent the same thing. If I put D here, if E goes that side, then D is equal to E inverse mod of phi n. When we have done all these calculation, that is, these all values are calculated, then sixth step says that what is my public key? So my public key is E and N. So whatever E value we have calculated, this E value and the N value what we have calculated, both will be corresponding to public key. Now you must be thinking, why there are two values for public key? Why not one value? Okay, why not one value? Because in during the encryption you will find that both are being used. Okay, so don't worry, I'll just tell you. Now let's take a look at private key. So private key is actually D and N. Okay, so remember, public key is E and N, and the private key is D and N. Now coming to the next part is about your encryption. So how Bob will do encryption? So this is written here. So it is actually we are having a plain text M Okay, whose value must be lesser than n. Remember, this is the length. The m's length should be less than n. Oh, m's value should be less than n. Right. Now, when you are having this m, then ciphertext can be generated using the public key values, which is e and n. So m to the power e mod of n is how we calculate the ciphertext. So ciphertext is equal to c is equal to m to the power e mod of n. And coming to your decryption, so at the Alice side, when Alice wants to decrypt it, Alice will be having the ciphertext. Then M is the plain text which can be generated or calculated using C to the power D mod of n. And if you remember, the private key consists of D and it consists of n. So both of these are there. That's why we are using two, because both of them will be used for this will be used for encryption and this will be used for decryption. So this is the public key pair and this is the private key pair. So both will be used for, one will be used for encryption and another one is used for decryption. Now, this was all about your key generation and your encryption and decryption. Now, I'd like to tell you, or I'd like to solve a problem using all these calculations. So, come to the next part. Okay, you are also required to do this. So, first of all, there is a question which is given to us that P is given to us, Q will also be given. Okay, now let's take at what is P and what is Q. So P is basically 3. Okay, Q is 11. It is given to us. Okay, so don't worry about that. Then the next value which is given, you see in the question, these values will be given to you. So what are the values which are given? The first value which will be given is P and Q. The second value what will be given in your question will be this integer e. You have to select, but generally when we are talking about calculations, then this e will be given. So in this particular question, the e value is given as your e is equal to 7. Okay, e is 7. And what else is required? Okay, what you want to encrypt. Now in this example, m is given as 2. Now this is the text, or this is the plain text which I want to uh, encrypt. Now, okay, you must be having this question that if it is numeric, we can do. What about when it is in text? Okay, and that's a valid question. How to encrypt something which is given in text? So nothing. You just have to take the place value of it. So, for example, if I want to encrypt cat, if I want to encrypt cat, okay, so what I have to do? First I have to encrypt c, then I have to encrypt a, then I have to encrypt t. So what is the value of c? It is 3, a is 1, and t will be something that you calculate of what is the place value of t in the alphabets. So that is how we can do the encryption using or converting your text into some plain text, or some into some your numeric values. So that is how the encryption must be done. Okay, now since it is clear now how to do it, let us do this step by step. The first step is we need to see. The first step is what was the, or not like the simply, what was the first step? P and Q. So P is given to us as 3, Q is given to us as 11. Second step talks about calculate n. So n is equal to P cross Q, which is 3 cross 11, which is 33. Okay, so we have got this n value. After n, what we need to calculate? We need to calculate the value of phi of n. So phi of n is how much? Phi of n says that we need to multiply p minus 1 and q minus 1. So what is this p minus 1 and q minus 1? So p value is how much? 2, and q value is 10, which is equal to 20. Okay, so this is our phi of n. Fourth one is, fourth point is what we need to do. We need to select e. The e is already given to us, but if it is not, then you have to take some value of e which is co-prime with phi of n. So in this case, it is written as 7. But how will you take it? See, e value is written at, it will be from 1 to phi of n. So what could be the possible value? See, phi of n is given to us as 20. We need to assume some value of e. What could be the correct value? So you can take anything which could be co-prime to 20, which is less than 20. But start from the 1. So 1 and 20 is not, both have common factor. So 1 of course won't be there because e should be greater than 1. 2 and 20 has common. 3 can be a co-prime to 20. You can take 3. You can't take 5. You can't take 6. But you can take some value as 7. Okay, 5 can't be there, 7 can be there. So you can take 3, you can take 7, both can be taken as e's value. In this example, e is given to you as 7. E is given to you as 7. Okay, now coming to the next point. Next is what? Next we need to calculate the value. um, like for example, you're having this one, right? We need to calculate, we have calculated e value is there. Now d can be calculated how? D is equal to e inverse mod of phi n. This is what. So this is what? Not 7 inverse mod of 20. Now how to calculate it, I hope you all know. If not, then you're not studying. And just for this example, I'll tell you. Other you have to do by yourself. Okay. So how to calculate 7 inverse mod of 20? See, 20 can be written as 7 multiplied by 2 plus 6. Now 7 can be written as 6 multiplied by 1 plus 1, and your uh, 6 can be written as 1 multiplied by 6 plus 0. Now in the reverse way, 1 can be written as 1 is written as how? 7 minus 6. 6 into 1 actually, but I'm not using it because 6 into 1 is 6. So no need to work on that. Now 6 can be replaced as 20 minus 7 multiplied by 2. Okay, so this is what we got. Why we why we replace 6? Because we are having 7 and 20, so no need to replace 7. It's not at all required. So we need to only replace the thing which is not there in this whole structure, which is 7 and 20. So we have to get in terms of 7 and 20. Now we have got everything. Okay. Okay, now we have got everything. Fine. Then what is required? 7 minus 20 plus 7 multiplied by 2. I just opened the bracket. So it is what? 20 multiplied by minus 1 plus 7 multiplied by 3. And if you remember, the inverse of this is actually this 3. So this d value is actually 3 because 7 multiplied by this value is actually taken as the inverse. So 7 into 3 is 21 minus 20 is 1. So it means we are correct. Okay. Now we have got this. Now sixth point is how. What is the sixth point? What is a public key? Public key is actually given as e comma n. Now what is e comma n? E is 7 while n is 33, right? So we'll write it like this. 7 point is, what is my private key? So private key is actually your d comma n. So what is d value? D value is 3, n value is 33. So now this is the key generation part which we have successfully completed. Now coming to encryption, how to encrypt. Encryption is very simple. We have to see first what is m value. M value is 2. As you can see, 2 is lesser than n. 2 is less than 33, so easily we can do. So how to do the encryption? C is written as uh, m to the power e mod of n. Okay, so m is what? 2 to the power e value is 7 mod of 33. So 30, if you do this, actually I have calculated already. I'll just write it down here. You can calculate it by yourself. I hope that you know it already and you have practiced. Then value is coming as 29. Okay. Now, just wait a minute. Someone keeps messaging. I think I'm getting from other. Okay, no worries. Okay. Now, C is equal to m to the power e mod of n. Okay. Uh, Now, when we have calculated this C value, when we have calculated this C, now we need to calculate. So this calculation actually you can do by yourself. You can try doing it. Now, what is decryption? How to do decryption? Decryption is simple. We are having the ciphertext as C. We need to calculate plain text M. C to the power D mod of N. Now C is what? 29 and D is to the power 3 mod of your N value is how much? 33. So when you do this, the value of course you will get it as 2. So we have got this M here, the C value as 29, and after calculation you will get the value as 2. But you need to in the exam you if it is given like this you have to expand it. I have written it in short because I know the answer for it, but you are required to solve it in a proper way, and you need to find out the solution for it. So this one, how to expand it and what could be the value. So this all expansion should be done. Someone please switch off your microphone. If I get further disturbance, I'll just switch off my class. So be attentive and don't switch on your microphone. Okay. Now coming to the next, what I was telling is this: you are having C is equal to m to the power e mod of n, and this you have calculated. Now this expansion you have to do in the exam if you're getting. This has to be done in the exam, and similarly for this also you need to expand it. Okay, so this was all about RSA, how it works. Now I will do one thing. I'll give you one sample question and you need to solve it using this RSA. Okay, so just give me a moment. I will search that question. I think I have written it somewhere. Uh, just a moment. Let me bring my, I think my notebook is just okay. So just a minute. Okay. Uh, Fine. You please do one thing. Write this down. Uh, Write in some other page. Okay. You can write it down here. Let us assume that we are having or P is given to us as 17. Q is given to us as 11. E is again given to us as 7. And your finally plain text M is given as 88. I need you to find out the value of D. What could be the value of D? What could be the public key? What is the private key? And what is the value of C? I want you all to calculate these all values Please write it down. Don't try to copy from anywhere. Uh, I want you all to solve it and let me know about the solution, how much you got. So these all values, the D value, what could be the D, what is private, public key, what is private key, and what is C. Try solving it and write down in the chat your answers. Okay, actually, some of the student has written uh, is if we write small cat uh, or capital cat, is it equal to C capital AT? See, actually, you see, when you are doing encryption in RSA, then it will be given to you that what could be the or in which way the numbers or the alphabet must be understood. Okay, so you don't have to worry about it. So it will be provided to you in the question. Okay, or if it is not, then you have to make your own assumption. So don't worry. In that case, you can take small letter as separate. You can take capital letter as secret, or you can take even the ASCII values. So it's up to you. But the thing is, it will be given to you in the question. So don't worry about that. It will be provided. But when it is not, then you can use any other approach. You can use ASCII value for calculation. That is well and good. But remember that whatever the m value is, its value must be less than n. So that is required. Then if you're having some special characters, then if you're using ASCII, then that will be covered, or else it will be given in the question that okay, if the ASCII values are like this, that is the number which is equivalent to it. So you shouldn't worry. I think my question is clear. My your query is clear to you. You have understood what I'm speaking. Um, any query regarding this? Okay. If not, then try solving the question which I gave. I hope I have made you understand. I think the query is you should have understood what I was trying to speak. That will be told to you that which approach you have to use. So this is the question. I hope you all have written, and if you have forgotten, you can take a look at it. Calculate the value and write it in the chat box. And all the values at one time. Don't write one values. The system has become slow. And one more thing, student, when I'm teaching at that time, try not to write anything in the chat box, because some that creates a sort of a confusion. After it, if you think it's very important, then you can write. I won't stop you, but try not to, because that actually disturbs the flow of the teaching. When I complete any topic, or it's better that you can speak. If I'm teaching and if I'm not getting anything, then at that time you can speak. That's well and good. Because writing in the chat box, actually, I don't recommend it for doing that. That is a bit frustrating for me. If you want to ask anything, you can speak in the middle when I'm teaching. That's fine. You can wait when I'm taking a bit of a pause. You can ask me the question. That is actually fine with me. Anyone got the answer? Again, I'll show it to you. This was the question. Okay, we have got one answer. That's good. What about other students? Don't copy the things what she has written. You have to do it by yourself. If you want to learn, that is what you need to do. Section 2 students have not got any reply. Okay, so I think I have given you sufficient time. Um, you have, I think many of you have got the right answer. The D value, what you should get or what you will get uh, is first of all n value, and n value you will get as 187, which I'm seeing that every one of you have calculated correctly. D value is actually 23. After calculation you'll get D value as 23. Public key will be your 7 and your 187. Okay, and private key is 23 and 187. So these are the values. C value after encryption, C value after encryption you will get as 11. D value is not 43, D value is 23. Sunita, D value is not 43, it is 23. Please check it once. And someone else has also written, yeah, I think one person has written D as 32. It's not 32, it's 23. I think that was a typing mistake. You please check it. Okay. But all of you have, some of you have done. Others, those who are sleeping, please wake up and solve it. Next, in section 2, I think 2 people have submitted till now. Okay, many of you have. And almost everyone has written it correct. That's great. D is 23, public key is 7 and 187, private key is 23, 187, C is 11. Correct. Okay, correct. I think all of you have done properly. Others, those who have not, you please check it once and solve it, okay? Because it is required for you to solve. Now, come out of the calculation. This is the last part which I'd like to discuss about this. Uh, you are having 5 possible approaches are there which can be used for for attacking RSA. These are the different approaches which can be used for attacking RSA. Then what are these things? The first thing is brute force, or the first kind of attack is brute force. So this is simple, like in symmetric encryption. What we'll do is you try to try all the possible values of the private key and try to break the encryption. So that is the first thing about brute force, and it is same as earlier what you have studied. There's nothing new in that. Next one is mathematical attack. Now, what is mathematical attack? See, earlier I told you that security of RSA lies in the product of two prime numbers. Okay, so one prime number is P, another one is Q. Now you see that when we multiply these two, okay, when we multiply these two, for example, if this is 3, this is 11, so answer is 33. So factoring 33 is somewhat easier. You can calculate that what are the factors of 33. But when this number is very huge, when P and Q is very huge, let's say P is of 5 length and Q is of, again, the same example I'll give you, 7 length. When you multiply these two, the resultant number will be very high, will be having many digits. So when it is having many number of digits, then computationally it is very difficult to factor it. Computationally it is very difficult to factor it. So what people are doing is they are trying to find a way by which we can factor the product of two prime numbers. So this is mathematical related attack where the people try to factor the prime numbers, the product of the prime. So this is the second type of cryptanalysis which could be done. The third one is related to time. Now, what is timing attack? This depends on the running time of the decryption algorithm. So in this, what the attacker does, the attacker tries to analyze by using any way. For example, in some system, if RSA is working, the person will try to find out, like, for how much time. Let's say any decryption algorithm takes 10 your millisecond. Okay, let's say that one standard system is there having, let's say, i7 processor, and RAM is around, let's say, 8 or 16 GBs, like, so something like that. Okay, so you can have some standard set of specification of a system. So what the attacker will do, the attacker will try to analyze how much time it takes for the decryption algorithm to decrypt the ciphertext into the plain text. Okay, so that is what the attacker will try to do. By doing that, the attacker can guess what could be the plain text. Now, listening to it may seem a bit of superficial, but if you are someone who has worked already in your security domain, of you if you have worked something on let's say timing based input injection, timing based input injection, if you have worked on it, you will understand what exactly I am speaking of. Actually, this is something which is very interesting. In actually, it can be SQL injection. It can be any injection which involves other kind of database languages. So timing based SQL injection is something, for example, or input injection is something like, for example, you are having a login page which contains a username, and the second text box is where you input the password. So here is the username, here is the password, and here is your submit button. So what an attacker does, attacker tries to input some or try to write a query in the user name field, where if let's say one such query could be like, for example, one username or the user one of such username which is active or which is there in the database is, say, admin. Let's say admin is a user weight, and password can be, let's say, attacking attacking 1 2 3 4 5 hash. Let's say this is the password. Okay, this is the password, and this is the username. Let us assume that we are just assuming, although password is of no use here in this case. So let's say that attacker wants to identify what could be the username. Now, for doing this, one way is to write a query in such a way that whatever we are trying to guess, like if we can write a query using a method called wait for. You can search it, or wait, I think wait for, you can check it once. So it can be written in such a way that if the length of the value whatever we put here, it is equivalent to this, then wait for, let's say, 10 seconds. Okay, so this is one way. And if it is not same, then it will be it won't wait for 10 seconds, it may give you answer in 2 seconds, let's say that. So if I put, let's say, uh, a user is username, so this is not matching, the length is not matching, so it may not execute, it may not wait for 10 seconds, it may execute only for 4 seconds. So this is one way by which we can identify the length. And also later on, you can construct a query in such a way that the first letter is matching with the first letter here, then wait for 10 seconds, the second letter. So this is a kind of a timing based attack which we can do in SQL injection. The same way timing attack can be done also in the your RSA, where the time plays a very crucial role. So how much time it takes for decryption, by analyzing this, we can have some idea that what could be the plain text or what is the message M. So this is what we need to understand. This is what we need to learn from this kind of attack. So this is another kind of cryptanalysis where time is a very important factor. Coming to next, I hope this is understood to all. If not, then you're recommended to learn this kind of input injection, and you'll find in OWASP site, or not OWASP. You can find it in OWASP, Web Application Security Threats. In that, you'll find it this one. You'll get some more information. If you are interested, you can learn it from there. Next one is hardware fault. This is very simple. If there is some fault in the hardware which is creating some problem, for example, any hardware which is used for generating the digital signatures, if there is some problem in that, then that fault can be leveraged for for attacking or for getting the plain text from the ciphertext. Although this is not in detail, much detail, but this is how simply it works. For example, even even I'm having one, digital certificate, a USB drive. Even I'm having that, which can be used for signing any certificates digitally. So if there is any problem in my USB drive, so any person can try to leverage this and try to gain some important information. So this is about it. Last of all is chosen ciphertext. I don't have to elaborate it. You can learn it more because we have already seen what is chosen ciphertext attacks. So this attack can be exploited. You know, this attacks actually exploits the properties of RSA algorithm. You are requested to search it on your own. Try to read this one, and you know what is chosen ciphertext. You can try to read from your book. You'll get some good information. So altogether, what I wanted to tell you is that these are the 5 ways of doing crypt analysis on RSA, and if any one of them is successful, then you can easily get the plain text out of it, or you can try to even guess the keys. So this is about RSA student. I think that's all from my side. If any query or any confusion is there, feel free to ask me. Uh, I'll just come out of the PPT. Any queries there? Any query or any confusion? Earlier, someone has written here public key is 723. It's not 723. Private key is 7183. No, no, no. What is this? Okay, someone has asked, is the value of P and Q depends on size of the plain text? No, no. See, plain text. If you are, for example, if you are encrypting something, actually, see, in a way, yes. Actually, in a way, yes. The reason is that if you are encrypting something which is a bit huge in length, okay, if it is huge in length, then of course then P and value must be taken huge. But generally, in the real life, P and Q will be this much larger that you don't even have to think about the length of M. Okay, in the real life it will be, because you won't be using 3 and 11 for encryption. Okay, you won't be using 17 and let's say 13 for encryption. You will be using something which, you will be using the prime number which is very huge. You can write a code for this, that generate a prime number which is having length more than 5. So from that, or more than 6. So for that, when from that, if you multiply those two, 6 digit and 5 digit prime number, then any plain text message which is short in length, then that can be easily encrypted using this. So of course, in a way, as I've told, that it is important for us to have P and Q. It is dependent on the plain text, but in real life that doesn't create a lot of problem, because generally P and Q is very huge in length. Any other query? I hope I made you understand this. Your query is solved. Any other query, anyone? Okay. Okay, it seems no one is having any other query. Uh, okay, then I will meet you. I think on Saturday. I may be on leave, and next week also I may be on leave. So Shiva sir may possibly take your classes for a short time. Then again, when I'll be coming, then I'll be taking your classes regularly. Or if time permits, I may take it from my home. Actually, I have a trip to my hometown. So if I go, then from there, if time permits, I'll take your lectures. But I also need a rest. Continuously, I'm working. So some rest is required. Okay, there is one question which is very interesting. I'd like you to try it once. Let me write it down. Um, the question is, for example, suppose you are you have done. Okay, let me select a pen from here. Suppose if you have encrypt or you have got some you have intercepted a plain text which sorry the cipher text whose value is 8. Okay, whose value is 8. Cipher text you have got whose value you got it as 8. Okay, now uh, you also have the value e which is equal to 13. Let's say e value is given to you as 13, and also n value you got it as 33. Okay, so these three are the values which is given to you. C is given, e is given, n is given. Now my question is, what could be the plain text? What could be the message m which was there? So these are the three values. You just try it. Actually, it's just a little bit of thinking. You will be able to answer it. I'm very sure about it that you will be able to answer this kind of question. So C is there, E is there, N is there. Can you find out M? So try doing it, reverse engineering in a different way. You have to think and you have to find out the value of M. Try doing it. Next time you can tell your solution. Fine, then that's it. Uh, Thank you all. You can disconnect now.